Hello and welcome to my first video. In this video series, I'm trying to show you how to deal with calculus. We'll start from the really basics, but we'll reach the derivative, integrals and other intriguing parts of calculus. To make sure that I'm saying everything okay and you get qualitative and valuable content, I'll use Thomas Calculus book as a guide for myself, so the credits goes for that book. Okay, so let's start with chapter 1. This chapter reviews the basic ideas you need to start calculus. The topics include the real number system, Cartesian coordinates, in the plane, straight lines, parabolas, circles, functions and trigonometry. But in this video we are going to talk about real numbers and real lines. So this section reviews real numbers, inequalities, intervals and absolute values. So let's talk about first the real numbers. Real numbers are numbers that can be expressed as decimals, such as, so let's take the number -3/4, and that equals to 0.750000 ... 1/3, that actually equals to 0.3333 ... and of course the square root of 2, which equals to 1.4142 ... Okay, the three dots in each case indicate that the sequence of decimal digits goes on forever. Okay, the real numbers can be represented geometrically as points on a number line called a real line. Okay, so I draw a line for you to show this. Okay, so let's find 0. Okay, he's here, and 1/3 is here, 1 is here, square root of 2, 2, 3, pi, and others. The symbol R denotes either the real number system or equivalent to the real line. So, real numbers. Okay, we distinguish three special subsets of real numbers. The natural numbers first. So, natural numbers, namely 1, 2, 3, 4, and so on and so on. So you can count your sheeps with these numbers. Okay, the second is the integers, namely 0, plus minus 1, plus minus 2, plus minus 3, and so on and so on. And the third is the rational numbers. Rational numbers. Namely, the numbers that can be expressed in the form of a fraction m/n, where m and n are integers and n isn't 0. For example, 1/3 is a rational number, or -4/9, which is the same as -4/9, or 4/-9, or simply just 200/13, or I don't know, 57, which is 57/1. Okay, now real numbers that are not rational are called irrational numbers. Irrational numbers. They are characterized by having non-terminating and non-repeating decimal expansions. For example, pi or the square root of 2, or the cubic root of 5, and others. Now we discussed the numbers, so let's talk about intervals. Just I need more space to write. Okay, so subset of real line is called an interval. Okay, so we'll write it for you. Interval. If it contains at least two numbers and contains all the real numbers lying between any two of its elements. Intervals of numbers corresponding to line segments are finite intervals. Intervals corresponding to rays and the real line are infinite intervals. Okay, a finite interval is said to be closed if it contains both of its endpoints. Half open if it contains one endpoint but not the other, and open if it contains neither endpoint. The endpoints are also called boundary points. Okay, so endpoints are also called boundary points. They make up the interval's boundary. The remaining points of the interval are interior points, and together comprise the interval's interior. Okay, so I'll draw a table for you for a better understanding. Here is a notation column, the set description, and the type, and the picture, of course. Okay, so we use this notation without the dot for a set of numbers, set of x, that a is smaller than x and b is bigger than x, and this type is open. And we used to draw it like this. We draw a line, and then we say that there are two circles here, A and B, because it doesn't contain A and B, and this is our interval here. Okay, so with this notation here, we use the set of numbers, set of x, where A is smaller or equal to x and B is bigger or equal to x, and this is a closed type. And we are writing this, we're picturing this as two dots here representing A and B, and the interval is the line between A and B. Okay, so these were finite intervals. Now let's talk about infinitive intervals. We use this notation for infinitive interval where the x is bigger than a, and this is an open type, and we used to picture it like a dot, no, a circle, because it's open. A circle represents a, and the interval goes to the infinity. But as I see, we are running out of time, so I will continue this video at the next episode. I mean this table in the next episode. So thank you for watching my video. Bye bye.